Hello everyone, thank you for watching this workshop. My name is Ali. I'm going to show you today a way to kind of set up these kind of keyboards. So these keyboards they call it like AD keyboard or better ADC keyboards. And the premise is very simple. Instead of a digital input like on and off, you have some resistors in them. And what those resistors do is giving a little bit different voltage on pressing each of them. So when you're putting a 3 volts in it, and then you press first one, for example, you give like full resistance, and then the 0 will be going. And then if you press this one, maybe it's like 0.6 voltage and volts, and then like similar thing just increases by maybe 0.4, and that way you are using only a single pin, which is shown here, as you can see, like out. And yeah, so you're having basically different outputs, and you can use it to control and get the values pressed. Now, the thing is, running these is not very straightforward as is in the digital inputs, and there's a lot of details. And I have created this for a project, and I thought maybe I share with you how I did it. And what we're gonna do is we want to define like left, top, right, bottom, and OK key, which is very useful for a lot of devices when you're working on them, like you're building a device and you want to give some options, controls, and you would put like 5 keys on the device, and then user can just control it without need to connect a hotspot or any mobile apps. It's very useful. So one thing we want to do is we want to connect this in event-based system, and also we want to have the option to press and hold, and then that would be triggering the like button press in some amount of time, like maybe 5 times per second. The thing is, in this video, I'm not going to go in line by line explain the code. Rather, I would just kind of go through the headlines, and we will build the project, and I will show you, and then you can read the code by yourself for more details. Now, I have programmed this one to, I guess, GPIO 35. Let me go to the torabian.io, and actually we go to the workshops and ADC keyboard ESP32, and then here I can download the project. So I'm going to download the project and go to like downloads, and then unzip the folder. Maybe I can create let's say mkdir work demo ADC, and then move the downloaded ESP32 ADC keyboard into work demo ADC here, and then I'm going there, work demo ADC. Now let's open it, and I'm gonna extract this one here, and then go to the folder again, code dot, and this should open the project. So 2 things we have in this project. One is how we are using it, like our main, and this is how like any ESP IDF app works. If you don't notice, like you're coming from Arduino background, yeah, ESP IDF is the native framework from the ESP company, chip company, and they are like wrappers around it, which makes it compatible for Arduino. So in this example, we have written code in ESP IDF, which is more towards real production level thing than Arduino. So back to the code, there's this ADC keyboard.c, which is kind of a library-ish. I didn't separate it to upload it somewhere as a library because you might want to modify it. It's not really that much of a deal. You just copy paste this file and put it inside your project. So we have some configuration on this. I'm gonna give a a little bit of this explanation. So the ADC channel is like which channel and the ESP you are using, so it's configurable. There are many different channels. For example, I think 8 channels or 9 channels on ESP32W room, and you have to consult the data sheet here, like ESP32 ADC channels, and there is a section analog to digital converter, and it has some explanation. I think there are 2 SAR on this, yeah, like ADC1, which is these channels, and ADC2. Generally, ADC1 is used, doesn't have much of an interference with the other pins. Though, yeah, so you can set that thing going back to the code, and then the GPIO pin. So this ADC is not exactly the same thing as pin. So you know, for example, this is pin 35. And then the ADC is 7, the channel is 7. Bit width, atom, and then ADC unit. These are like for configuring how much of bit, like the size of the reading of analog pin is. Voltage reference is another value you can set as a fallback if it's needed. I guess it's not really needed in this scenario. We're just setting it for no reason though. All right. So we don't have to need it unless we wanted to kind of read and convert this into a voltage, which is not something we want to do, but let it be there. And then there are 2 important things, which is a wait cycle long press and long press emit wait. So if you push the button, like if I press this, it's gonna emit 1 time. But then the thing is how long I should wait until I realize this is a long press. So the wait cycle long press is how many cycles we have to wait. So in this code, the cycle is, I guess, 25 or 30 milliseconds to read the next time. And it means if we set 20 cycles, then 600 milliseconds afterwards, it starts to consider as a long press. And then emit long press is, long press emit wait is with different value, which if you're holding it, how many times per second of holding it that's going to be emitted. So you don't want that be too many oftens, like the left button being pushed. Maybe I want to hold it for like faster going to the 10 options, but I don't want to be so fast that I cannot get a feedback, for example, from an LCD or LED that like it's going to be hard for me to navigate through. And the topic and sample count. So sample count is like you're getting the average of the voltage readings. The thing is, when you're reading ADC, it's not really accurate. It's not like you can read, this is like exactly 0.002 volts. It a bit fluctuates around a number, and the sample count makes it a bit more accurate to like see like what is the average of that value. Of course, you can work with this, but I think the sample rate of 10 seems to be very fine. Even I think 5 would be perfect. Now, one thing I'm gonna do is going to explain the main file, which is this ESP keyboard. So I have defined up, down, left, right, OK keys. You can define many keys as you want. You know, if this device had like, I don't know, 50 pins and 50 different voltages, it could come out. You could define it this way. And very important thing is you have to set up the ADC keyboard. So we are saying the channel is channel 7 and the GPIO is 35. So GPIO 35 has the channel 7 on it. Let's put it this way. And for some bizarre reason, you have to define both of them. There is no mapping, or maybe there is, I don't know. That 35 is the channel 7. And then the topic is the main keyboard. The thing is, with this library, you can have multiple keyboards. You can integrate multiple keyboards and then just set them up, and they could work alongside each other. That's a very good benefit of this type of writing code in this library-ish thingy. Important thing is you need to measure manually, see like how much is the voltage of each key press if you don't know, and then you will create a map like this, a range like this, and say 0 to 100 is the left key because of the resistance, and then the resistance is a bit lesser, and it's going to be up key. Down is lesser than that, and until the OK button on the very right hand side. And then of course we have to create the listener cycle, which is like indefinitely listens to the changes, and it's gonna make some comparison and then log some stuff, and then in the end it's gonna call these callback, which we are passing to. In our case is here. The important thing is we could, and in my project I'm putting this into a queue, so it's gonna send the message to the queue, to the other core, to change the state of the system and then navigate through the options or control other pins, output pins, which I mean that's another thing. And yeah, so you can modify this when you got the event came back. So let me connect this one real quick. I'm having this kind of module like this, and it is ESP32 W room, and I'm gonna connect the black pin to 35, which is out. So you see like there's an out one if you even look at the picture, and then the ground is the 3.3 is connected to VCC, and obviously automatically the other one would be the ground. Important, this is not a 5-volt input. Make sure you're connecting to 3.3 volts, not 5 volts. We will fry the chip. And yeah, so it's from like physical perspective, we are all set, just connected. It's very simple, like just 3 lines, nothing can go wrong or bad unless you connect it to higher voltages. I'm gonna go and do what? I'm gonna do EFIDF.py, flash, and monitor. The thing is, if you are coming again from Arduino world, IDF tool chain is a little bit different, and you need to learn it a bit if you don't know about it. But when you get it up to speed, you will realize how better and easier it is to use the native solution, and how much things you don't need a wrapper around it. And yeah, I mean that would be like a different experience on that hand. Until this builds and goes to project, I want to show you this keyboard workshop. So if you come lower, you realize you need to have driver ESP command ESP requires into your CMake lists. Of course, I have put the code from the main in here. Okay, that's cool. That's one thing I have seen. It's a mistake I have to fix, hopefully. And then here's the library code. So if you ever wanted to use that in existing project, you don't want to download everything, you just can come here and copy the code and put it. So you can find it from workshops, and then I believe building an ADC keyboard on ESP32. Now it's already compiled. So I'm gonna press the left key, and it says it's number 3. And then when I release it, it says key released. So now I'm gonna hold it, and you see the key 3 is being like triggered with that amount of emit option that we provided. So of course you can modify it as an option when you're configuring. So like 2 changes per second happens, something like that. And now I'm using the bottom, top is number 1, right is number 4, and 5 is basically the OK button. Well, this is like physically placed together. There are other keys which are like 9 different keys, and then it's just a technique you can use basically with everything. You might want to kind of go and realize, okay, how we get these numbers is through trial and error, I would say. So one thing you could do is you could just come here, and when you're reading this average, you could log this value and you would see what the value is coming. And then based on that, you say, okay, if it's between like 200 and 600, then it is this key. Now, if you have some data sheet, still you might want to do this because they're usually not that accurate or might be a bit different before you can go to production or anything. So basically that's it. I mean, thank you for watching. I hope it was useful, and see you another time.